Hello, I am Brenin Rhodes. I'm a senior software developer at Smile Digital Health. And this presentation of us is about building questionnaires with CQL libraries for use with the SDC populate operation. I will be focusing mostly on the Vinci prior authorization burden reduction use case, and where we'll be using common CQL assets, but a lot of what we talk about will be applicable for all smart on FHIR applications that use questionnaires. So here we have our sequence overview diagram of DTR and prior authorization. And you can see highlighted where CQL comes into play within DTR. We have a couple use cases here. First is item population using data available in the EHR. You do this with extensions such as item population context, initial expression, and calculated expression. Then we have questionnaire behavior as well. Enable when you can use CQF expressions on all of these different properties and result calculations such as unit and ordinal values. A little bit about the data flow and context of DTR. Smart on FHIR app launches from the EHR, passing the launch context information. It receives the questionnaire as well as any supporting libraries in CQL and value sets in a packaged bundle. And then it uses that to populate, pulling data from the EHR when it can. So for example, here we have an initial expression extension on a questionnaire item that is pointing to the patient birth date. Fairly simple example, and it looks remarkably like FHIRPath. CQL is a superset of FHIRPath that enables capabilities that are critical to DTR support, such as data access expressions, query capabilities, and calculation capabilities, and very importantly, modularization and reuse through libraries. So here we have another example of an initial expression within a questionnaire item. This is looking at the body surface area for a patient. So we have an expression, fairly complicated expression written in there. It's grabbing the first observation from the patient with the proper status, and the code is what we're looking for, ordered by the issued date. So here's the same expression written within a library. You can see we pass in, or we reference rather, the library itself within the questionnaire at the root level using the CQF library extension. So we're referencing that. And then within the item itself, what we can do is reference the expression itself. Makes it a little cleaner, easier to reuse. And if you don't have that data available for you, if you don't have the observations with the proper code, you can write a calculation to calculate that based on the most recent height and weight. Here's an example of that. We're using some pre-existing expressions written inside of the US Core Elements library here. But if the patient weight and height are available, then it will use those. And if it has a most recent BSA from that previous example, it will use that. So this is showing how we have shared libraries. Some other examples of shared libraries are FHIR helpers, FHIR Common, you may be familiar with. And what we have is a questionnaire-specific library that is using those, and then the questionnaire references just that one library. That is the best practice from a quality measurement and decision support authoring. This way you have all your artifacts defined in a single library. Questionnaires may reference any number of libraries, but if more than one is referenced, you must qualify the name of the library within the expression. All right, moving on to context within CQL. This is similar to compartment in FHIR. It establishes the scope of data access for queries. We have a simple example here that's just retrieving all allergy intolerance resources for the patient in context. Within a questionnaire, that context is established by the launch context that is passed from the Smart on FHIR application. And that corresponds to the launch context of patient within the questionnaire. As you can see, we've got an extension for a questionnaire launch context. Will be at the root of the questionnaire resource, stating that we're looking for a patient resource to use to populate the form. And this corresponds to the context patient within CQL. You can also pass in some other launch contexts, most commonly for DTR at least, service request and coverage. Again, they correspond to launch context parameters that are provided to the application, and they correspond to the context parameters within the populate operation. Within your CQL library, these are declared as parameters with the same name that you set up for that launch context on the questionnaire. So we've got our coverage, FHIR coverage, and our service request, which is a FHIR service request resource. In addition, any CQL expressions may make use of the questionnaire and questionnaire response resources to access the form and responses as described in SDC using the following variables. And now we look at the item population context extension. This can be specified at the group level, providing an item context for use in populating child items of the group. So we have a patient history example here. This is listing all problem list items, and it returns a tuple with all of these different properties. Then on our next slide, we see here we have an extension on the group item for the item population context. When you do this, you must specify a name for this expression, something we don't normally do. But in the item population case, this is required as this becomes the variable name of the value that gets passed into subsequent evaluations for the child item. So you can see here we have our patient history, including age at diagnosis. It's pulling that from the CQL library. And then it's just pulling the diagnosis property from that result. And you would repeat this for all the different items, the child items that you want to specify that on. Moving into data requirements. So how do you know what data you want to pass or what data you need to retrieve in order for your evaluation to be successful? This can be done by looking at all the retrieve expressions that are referenced within any expressions within the library or within the questionnaire. It formally consists of any data that satisfies the effective data requirements of the expression. And it's the data that is needed to ensure successful evaluation of a CQL expression. So here's an example, fairly simple expression, just give me all observations. Again, this will be within the context of the patient. And that will manifest within the library data requirements as this observation with a code filter. You can also add date filters into data requirements if you know the time frame that you're looking for the data within. But this correlates to this simple FHIR query here, observation subject equals patient, code in this value set. So when we're retrieving data, we have kind of two steps. We've got our initial data retrieval for any expressions that are referenced by any items that are visible when the form is open. These are your item population context and initial expression extensions. These data requirements can be collapsed. So if you have multiple items that are using the same data requirements, you can make sure to collapse those requests to limit the number of requests hitting the server. And they can be performed with value sets or expansions, depending on the terminology considerations. And then we have our subsequent data retrieval for any expressions referenced by any items that are newly visible to data changes in form state. This data may be cached, and that's something to note, that when this data is cached, applications must ensure data is being displayed and it is not stale, making sure that you've retrieved the most recent data if you need to. Some other terminology considerations. If we return to this example here, we're assuming that the FHIR server supports the in modifier here. and that it either has or can get the value set and perform an expansion on that value set. So if the server does not have those capabilities, what are some options we have? We can choose a less selective filter or no filter at all, and then filter within the CQL itself. Or we can perform an expansion and inline the codes for the retrieval process. Note that when inlining large value sets, the resulting search may overflow practical URL length restrictions. You can either post or split those out into multiple requests and combine the response. And some other things to consider for performant data access. Ensure that the application requests the minimum amount of data required to present the form in current state. Collapse data requirements to ensure minimal data requests, and choosing different filters or search parameters based on client capability and performance characteristics. And now we're going to jump into a demo. So here we've got, make that a little bigger, example questionnaire. This is for genetic, what is it called? Genetic molecular testing for pre-authorization. So you can see what we have here is a few, we've got our CQF library extension at the top, referencing the GMTP initial expressions CQL library. And then we have a few launch context extensions. We've got one stating our patient, and we have a couple more, one for a coverage resource and one for service request. And then we have some initial expression extensions on our items. Now I will hop over into Postman. What I have running is just a local instance of the JPA server starter with the clinical reasoning module enabled. I will quickly post this questionnaire bundle and the questionnaire, the patient data bundle onto the server. And then we will run populate. Pull this out so we can get a better look at it. Then you can see we have our questionnaire response that is referencing the subject, which is the patient context that we passed in to the populate call when it was authored. And then we have on our items, we've got answers. And note that we also have extensions stating that this answer was provided by CQL. You can see that all the way through. We've got values for all our different items. And then this also provides a way for the clinician to, one, verify that this data is correct that was pulled from the EHR, as well as changing it if need arises. And oh dear, I started at the beginning. All right, so my contact information, you can reach me here at Smile Digital Health. Here's my LinkedIn and on the Zulip chat as well. And now into Q&A. These are a few links, the DTR IG, the CQL assets for FHIR. It's an IG we're working on where we've got some examples. There's a few common libraries in there that can be referenced and used. And then the clinical reasoning on FHIR for Java. And of course, SDC makes it all possible. Any questions?
Thank you for your speech. First of all, I want to ask you about your declaration at the beginning of presentation. You said that CQL is superset of FHIR. Is it true for now, when sixth version introduced service API for updating data and instancing variables which can gain access to any information from any server?
I want to say yes, but I'm going to need someone else to answer that question. We're looking at you, Brent.
I mean, yes, because what we're doing, we just balloted FHIRPath, the next version, and we're balloting CQL after that. And any changes that are made in FHIRPath, we make the equivalent change to CQL. So they were initially built as CQL as a superset of FHIRPath, and we're maintaining that as FHIRPath evolves as well. So yes.
Excellent. I was not wrong.
Yeah, thanks. And continuation of my question, are there any reasons to be so complicated in face of initial expressions? So now we can declare simple FHIR query for obtaining data from server and not declare it like you show an example with resource type, then filters described in JSON, and yeah. Do you think that it's overcomplicated now? Because seems in 6th version it can be done more easily.
I think that what you gain from using CQL, while it may be a little more complicated, is the modularization and reuse of libraries. In addition to being able to do more complicated things like calculations that you can't really do within FHIRPath. You know, like the example I showed where you've got this calculation here for body surface area, right? That's a little more complicated to do within FHIRPath, whereas what we have here is just a simple expression that can now be reused in multiple questionnaires without having to write that same FHIRPath over and over and over. I think that's one of the core benefits that you get from using CQL to populate. It may be intimidating, but it is very powerful. Any other questions?
No. You have.
I think there's time.
Did you say you could write an expression that uses the answer of another questionnaire item?
Yes, you can. Do you mean for behavior, or there's a couple ways of doing it?
For calculated expressions, but for initial population, I thought I saw on the context slide that you said you can refer to other questionnaire items, and I was surprised to see that. I guess.
Yes. So as long as it exists before the item that is being evaluated, you can reference it within the questionnaire response, and you can always reference items within the questionnaire. And yeah, those are, so all of these, let's see, where is that slide? But all those, yeah, these variables here all get passed in to every evaluation call that CQL is doing, right? So they're always available, and it's iterative, so it changes every time, right? We pass in a new questionnaire response to every evaluation, because if we've answered previous questions, they can now be referenced by subsequent questions through the use of these variables. Does that make sense? That's SDC. Right. 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 Right.
And then you have to like do the life cycle, right?
Yes.
Okay.
Right.
I have a simpler question. You were referring to standard CQL libraries. Are those like or you know, I know some of the standard CQL libraries, but the ones that you showed, just are these part of SDC or?
They're part of this US CQL IG here. This
Okay.
second one, that's where the US core common currently exists. But I think there are a couple other ones in there. I'm not sure if we're going to move them out. There's US core common as well as US core elements. But yeah, those are available. And we have several examples on there. The GMTP questionnaire is just one that I showed. There's a few others on there. And we're continuing to add to that and build on those examples. So,
Right. Thanks a lot, Brenin, for the presentation.
thank you.